valve actuator. The actuator operates the stem and disc assembly. An actuator may be a manually operated hand wheel, manual lever, motor operator, solenoid operator, pneumatic operator, or hydraulic operator. In some designs, the actuator is supported by the bonnet. In other designs, a yoke mounted to the bonnet supports the actuator. Except for certain hydraulically controlled valves, actuators are outside of the pressure boundary. Yokes, when used, are always outside of the pressure boundary. So the actuator is going to be installed normally on top of the valve, away from the system pressure, so it's not exposed to system pressure at all. And we may have a hand lever, like that's shown now, or we may have a hand wheel, such as that's shown now, or it may be operated by a motor, like the one we're looking at now, or perhaps it will be a pneumatically actuated valve, such as that displayed now. So there are different types of design. There are also the solenoid and hydraulic types of actuator. Generally, when we're using a manual lever, this is going to be for a relatively small or medium-sized valve. A lever is typically only used for a 90-degree or quarter turn valve. This is simply because you only want to turn it around 90 degrees. You don't want to wind it round and around with a lever. If you are doing that motion, winding it round and around, then you're going to use a hand wheel. For larger types of valve or larger quarter turn types of valves, you're going to use a gearbox normally, and then you're going to use a hand wheel again. This is simply because you need a lot of torque to turn these larger valves, and you're normally not able to do that by hand, at least not directly. So you use a gearbox, and you'll use a planetary style gearbox, and you'll manually wind the gear wheel, and that will close or open the valve proportionally. So in other words, you'll be able to apply very little torque on the hand wheel, but you'll get some incremental movement on the valve. So although you'll lose speed, you can't actuate the valve as quickly, it does make actuating the valve a lot easier. Pneumatic actuators are a lot larger than hydraulic actuators. That's simply because the pressures are a lot smaller. A hydraulic actuator may use pressures up to 150 bar or more, whereas a pneumatic actuator typically may use 8 bar or 6 bar. This is what we refer to as control air. You use different actuators for different things. A solenoid actuator is ideal for on and off, but is very poorly suited for throttling. So it is either on or off with no flow regulation whatsoever. So although the valve design may be well suited for on, off or throttling, it is also the actuator that has to be considered. It's pointless having a globe valve that is well suited for throttling if you are then going to have a solenoid actuator. There is only ever the position of on or off for the solenoid. There's not going to be the position in between. So having the globe valve there is not necessarily an advantage concerning flow control. You could just as easily have a different type of valve fitted. So the actuator has to fit the design of valve in order that it can be applied correctly.